Okay, today we're going to talk about unfired pressure vessels or air flasks. Okay, for this task, the safety hazards and precautions are going to be your general use of PPE, as well as being mindful of the hazards presented when we increase the pressure in these pressure vessels to the point to test the safety relief valves if you decide to do it that way. Okay, the task we're going to talk about on unfired pressure vessels is to examine the marking plate in accordance with regulations. There's supposed to be data on there that talks about the maximum allowable working pressure, what standard it was inspected to and fabricated to, as well as which Coast Guard Inspections Office first certified it. The main requirement is that they be legible, and as you can see on these two unfired pressure vessels that have been out of service for 15 years now, that's not the case. They've been painted over, and this one is rusty. Sometimes you can take a flashlight and throw a profile to get information, but today that wouldn't work on either of these two plates. Another option is to get the vessel representative to bring a wire wheel and try to take a wire wheel, a soft wire wheel, that would remove the paint and the rust without damaging the letters that had been imprinted on the plate. And then the worst case scenario is we just don't have the data on the plate available to us at all. There is a fabrication information contained on what's called the UA1 sheet, and every ASME and or Coast Guard approved unfired pressure vessel had a UA1 sheet originally when it was fabricated, and you can require the vessel representative to find and or provide you that UA1 sheet, which will have all the data that you would need to see on a marking plate. The only thing is to remake this marking plate requires a competent authority under the National Boiler Inspection Code to be able to restrike the data on a data plate and then replate a pressure vessel. You and the vessel rep cannot do that. That would be called an R1 plate. Oh, by the way, I misspoke earlier. The fabrication data sheet that we spoke of earlier is U1A, is the proper name for that sheet when you request it from the vessel rep. Okay, to inspect a pressure vessel externally is really very generally to just put eyes on the whole external surface of it to look for corrosion and or dents or impact structures. So all you can do is verify that it's painted or unpainted, and generally look for rust. Now, the potential areas where you may see the corrosion setting up first on these unfired pressure vessels are going to be usually around the appurtenances, which are the places that the pressure vessel has openings for either threaded connections, pressure safety relief valves, or pipe entries, and then along the axes. So you want to get underneath it, the lengthwise axis on the underneath side where any condensation may come and form before it drips. That's going to be a place to look for corrosion, as well as on the top. Now, the next thing that you have to determine is the 5-year inspection that has to be done. These things have to be either internally examined every 5 years or hydrostatically tested. The default position of the regulations are to hydrostatically test these. That is not the industry standard or norm. Most pressure vessels, unfired pressure vessels, are made available to be inspected internally. Even though the requirement is to hydrostatically test these, most operators will choose the alternative the regulations offer, which is to open them and do an internal inspection in lieu of a hydrostatic test. That's why unfired pressure vessels will always have openings that can be undone and looked into. On this one, you'll see a pipe connection here and one here. These are small unfired pressure vessels, so you're going to have small openings. The reason for two is on this type of receiver, air receiver, you need to open one hole so that light can get in while you're looking in the other hole. And if you have one in your office, you would also want to bring a bore scope out here so that light can enter one hole and a bore scope, you can go in here and look. And again, on the inside, we're just looking for corrosion. General surfaced orange powder is okay. You're looking for deep pitted orange peeling corrosion on the inside. Again, you'll find it along the axes, either the bottom axis lengthwise or on the top axis, right at the very top where you would think corrosion condensation would drip down. Right along that line is where you'll find corrosion. So, internal examinations are the norm. The alternative or the requirement of regs is hydrostatic. Those are very rare. A couple of other things to look at on unfired pressure vessels is see the piping leading to and from the pressure vessel. We also see pressure gauges so that we know how much pressure is in the pressure vessel, especially as we are bringing the pressure up to test safety valves. Now, the thing to know about pressure gauges is they're always most accurate in the mid-range. Occasionally we'll see pressure gauges that are missized for the amount of pressure they're made to routinely read. So this pressure vessel normally operates at 150 psi and the safety lifts at 200 psi. Obviously, we wouldn't want a pressure gauge with a scale of 0 to 200 on here because a pressure gauge is most inaccurate at either end of its scale. If this thing sits at 150 psi most of the time, then I would want a 0 to 300 psi pressure gauge to be on here because then it would be most accurate in its mid-range most of its functional life. Another thing to make note of on the safety relief valves is you can never have a valve that would isolate the safety valve from the pressure vessel it protects. Occasionally you may see piping connected to the pressure vessel and the safety valve connected to the piping a little bit physically away from the pressure vessel. You would never want to see a valve there. There are very few instances where a valve would be allowed, and they're usually involved with the Outer Continental Shelf inspections world on either pressure vessels for human occupancy or in cases where there are two safety valves and you need to take one off and service it while the other is still functioning. These are very specific instances, and you can ask your verifying officer at your unit about those in the future. One safety item the inspector must always be aware of is the compressor system that is feeding air to the pressure vessels. When you are asking the vessel rep to increase the pressure on the air receivers to either test the safety valve or anything, occasionally the compressor system is not designed to put enough pressure in the vessel to lift the safety valve. In that instance, you may accept them taking the safety valve off and either bench testing it or putting a new one on that has certification papers with it. There is a safety alert out right now that we should all have read because there is a hazard. You see this little safety valve here and here that's part of the compressor. The safety alert discusses that you never want to block these off or gag these valves from functioning properly to try to achieve the pressure that you want on the pressure vessel. It's very dangerous. If you manipulate these safety valves at all, you can actually have compressors letting go and blowing up in an engine room, and that's the last thing we want to do. So make sure you never manipulate the valves on the compressors themselves, and read the safety alert. Now, to wrap up the subject of inspecting pressure vessels, if during your inspection you do find corrosion that is of a concern, then speak to your local verifying officer at your unit. The rules and regulations on making repair proposals and repairs on pressure vessels are very detailed, and you should involve your verifying officers at your unit. To summarize unfired pressure vessels, we covered today inspecting the data plates and making sure they are legible. We talked about inspecting the pressure vessel externally. We discussed the ability to determine the difference between a hydrostatic test and an internal inspection, and when each is called for. We talked about witnessing a hydrostatic test if it is called for. We evaluated the function of the pressure gauges, and we witnessed operation of the safety relief valves. The special considerations you may encounter is, if you do encounter corrosion on a pressure vessel, is determining the repair options available to you by speaking with a verifying officer.